All right, let's talk about organic chemistry. I know for so many of you ICSE students, just hearing those words can be, well, pretty intimidating, right? It's often the toughest part of the whole chemistry paper, but it really doesn't have to be that way. So in this explainer, we're going to break it all down. We're going to decode question 8, the big one, and give you a rock solid strategy so you can walk into that exam feeling totally confident. I mean, does looking at a whole page of hydrocarbons make your head spin? Yeah, if it does, trust me, you're not alone. It's famous for being a super tricky topic. But here's the secret, okay? It's not about trying to memorize every single thing in the textbook. No way. It's all about knowing exactly where to focus your energy. And that's exactly what we're going to get into right now. Okay, so first things first. We've got to understand the building blocks. See, question 8 isn't designed to test you on everything. It's really about mastering just a few key chapters that are the absolute foundation for this entire section. So seriously, forget trying to cram the entire textbook. Your focus? It needs to be laser sharp on these 4 pillars. We're talking alkanes, alkenes, alkynes, and alcohols. And with alcohols, you really want to zero in on ethanol and ethanoic acid. Believe me, pretty much every single part of question 8 is built on a solid understanding of just these core topics. All right, so we know which chapters to study. Now let's get even smarter about this. We're going to zoom in on what specific concepts from those chapters show up over and over again. This is where we get really strategic. So instead of just randomly memorizing stuff, I want you to focus on these 4 super high-yield areas. First up, IUPAC nomenclature. You've got to learn how to name these things, right? It's like learning the language of organic chemistry. Second, you absolutely have to know the difference between substitution and addition reactions. This is the key to figuring out how molecules are going to act. Third is isomerism. That's a concept that just always seems to pop up. And finally, those functional group tests, the practical, hands-on lab skills they just love to ask about. I'm telling you, master these 4 things and you are going to be in such a great position. Okay, let's really dig into reaction types because I know this is where a lot of students get mixed up. But honestly, it all boils down to one simple difference. Think about alkanes. They're saturated, right? They've got all these single bonds. So they can't just add more stuff. They have to substitute. It's like swapping one player for another on a full team. But then you have alkenes and alkynes. They're unsaturated with those double and triple bonds. They've got room to play. So they undergo addition reactions, where new atoms can just jump right in and join the party. All right, next up is isomerism. I know, it's a word that sounds super complicated, but the actual idea behind it, it's surprisingly simple. Just think of it like this. You have the exact same ingredients, but you follow a different recipe. You're working with the very same atoms, same number, same types, but you just connect them in a different way. And boom, you get a totally new structure. So the classic example you always see is butane, which is C4H10. You can have it as a simple straight chain. We call that N-butane. Or it can look like this branch structure, which is isobutane. See? Same formula, but they're built differently and have different properties. And here is the most important takeaway for your exam. Listen up. You will almost certainly be asked to draw these kinds of structures, so get practicing. All right, you ready to build some serious confidence? Let's do it. The ICSE board, well, they love to repeat certain classic questions. So we're going to do a quick rapid-fire round with a few of them. That way you'll know exactly what to write down the second you see them on the paper. Okay, first one. Imagine you're in the exam, you see this question. What is observed when ethene is passed through bromine water? Okay, think back to what we just talked about. Ethene is an alkene, right? It's unsaturated. So what's going to happen? The answer is all about what you can see. The key phrase is, the reddish-brown color of the bromine matter is decolorized. And why does that happen? Well, because ethene does that addition reaction we talked about. It breaks its double bond and lets the bromine atoms join in. This uses up all the bromine, which makes that reddish-brown color completely disappear. And that, right there, is the classic test for unsaturation. Okay, next classic question. This one really tests if you get the fundamentals of alkanes. Why are alkanes also called paraffins? The name paraffin literally comes from Latin words that mean little affinity or little reactivity. So why is that? It's all because they are saturated. Simple as that. Those strong carbon-carbon and carbon-hydrogen single bonds are just incredibly stable. They don't break easily at all. And that makes alkanes, well, pretty unreactive. So the key point you have to make in your answer is linking that low reactivity directly to their saturated single bond structure. And here's our last classic question for this little round. This is a standard lab prep method they expect you to know. So what gas is produced when you take some water and drip it onto calcium carbide? The answer is ethine, and here's a pro tip. It's really important to know both its official IUPAC name, ethine, and its common name, acetylene. Why? Because the question could use either one, and you don't want to get caught out. This is an absolutely must-know reaction for making alkynes. Okay, you've got the fundamentals down. Now for the really fun part. Let's put on our prediction hats and look at the trends to figure out what you're most likely to see on your 2026 exam paper. This is how you really get an edge.
Now, based on what we've seen in recent papers and what the curriculum is really emphasizing, we can make some seriously good guesses. So you're going to want to pay close attention here because these topics, they have a super high chance of showing up.
Okay, so a huge trend we're seeing right now is comparison questions. They just love asking you to compare how ethane and ethene react with chlorine gas. And the whole thing hinges on one crucial difference, the conditions. Look, ethane is an alkane, so it needs that kick from sunlight to get its substitution reaction started. But ethene? It's an alkene, so it undergoes addition easily, no special conditions needed. That tiny detail, the presence or absence of sunlight, that is exactly the distinction they want you to point out. Here's another reaction you have to have locked in your memory: the conversion of ethanol into acetaldehyde. The absolute key here is the reagent you use, hot copper oxide. Just think of it like a simple recipe. Step 1, start with ethanol. Step 2, react it with hot copper oxide. Step 3, your product is acetaldehyde. Breaking it down like that makes it so much easier to remember. And let's add a few more high probability items to your study checklist. First, you need to be ready for the oxidation of ethanol all the way to ethanic acid. Second, make sure you know how to use alkaline caminophore. That's another really common test for unsaturation. And third, keep practicing your drawing. I'm not just talking about simple chains. You need to be able to draw a thiene and clearly show its triple bond, and even a specific branched isomer, like isopentane. Whew, okay, we have covered a lot of ground here. So let's bring it all together. I'm going to condense everything we've talked about into a final, super actionable study plan that you can use for your revision. All right, let's put it all together. This is your 4-step battle plan to absolutely conquer question 8. You ready? Number 1, get obsessed with functional groups. Know your OHs and your COOHs. Number 2, master the difference between substitution and addition reactions. It has to be second nature. 3, practice drawing structures over and over and over again until it's just muscle memory. And finally, number 4, don't just memorize the reactions. You have to memorize the specific conditions and catalysts so that make them happen. That's where the real marks are. So there you have it. That is your complete roadmap to acing organic chemistry. The only question left is, which concept are you going to master first? Don't wait. Pick one of these things we talked about, dive in, and start building that mastery today. You've got this. Good luck.